Imagine you are standing in the middle of the Sahara Desert at high noon. The air temperature is 120 degrees Fahrenheit, and there is not a single cloud in the sky to offer you shade. You have no air conditioning, no electric fans, and no ice-cold water sitting in a refrigerator. This was the reality for our ancestors for thousands of years. They didn't just survive these brutal conditions, they thrived in them. They built empires, hunted, and migrated across the hottest landscapes on Earth. How did they do it? The secret isn't just biology. It is a masterclass in ancient engineering and behavioral psychology that we have almost entirely forgotten. To understand how they survived, we have to look at the human body as a piece of biological hardware. We are actually one of the best heat dissipation machines on the planet. Most mammals have fur. Fur is great for insulation in the winter, but it is a death trap in the heat. Humans evolved to lose our thick coat of hair. This allowed us to develop millions of eccrine sweat glands. When you sweat, water exits your pores and coats your skin. As that water evaporates, it draws heat away from your blood vessels. It is essentially a natural evaporative cooling system. But this only works if you have access to water. In the deep desert, water is scarce. So, how did they handle the hydration crisis? Enter the Qanat system. Developed in Persia around 1000 BCE, this was a massive underground irrigation network. Ancient engineers would tunnel for miles through hillsides to tap into groundwater reservoirs. They kept these tunnels underground to prevent the water from evaporating in the sun. This was basically an ancient, gravity-powered, climate-controlled plumbing system. The water arrived at villages cool, clean, and plentiful. But water is only half the battle. You still have to handle the physical environment. Ancient architects were masters of thermal mass. Look at the mud brick homes of the ancestral Puebloans in the American Southwest, or the traditional architecture of the Middle East. They used thick walls made of adobe, stone, or clay. These materials have high thermal mass. During the day, the exterior walls absorb the intense heat, but that heat takes hours to travel through the thick material. By the time the heat reaches the inside, the sun has gone down. The temperature outside drops, and the walls begin to release that heat back into the cool night air. The interior stays comfortably cool throughout the day. It is passive cooling that requires zero electricity. Then there is the concept of the wind catcher, or the malkaf. In ancient Egypt and Persia, buildings were designed with tall towers that caught the higher, cooler breezes above the stagnant desert air. These towers funneled the wind down into the living space. If there was a fountain at the base of the tower, the air would pass over the water, drop in temperature through evaporation, and blow a cool breeze through the entire house. It was a 3,000-year-old air conditioning unit that worked without a single watt of power. Clothing played a massive role too. We think of less is more in the heat, but ancient desert dwellers knew better. The Bedouin people of the Arabian Peninsula didn't wear tank tops and shorts. They wore loose, flowing robes. These robes create a chimney effect. As the air heats up against your skin, it rises and escapes through the top of the garment. This draws fresh air in from the bottom. It keeps your body ventilated while protecting your skin from direct solar radiation. The loose fit also traps a layer of air between the fabric and your skin, acting as insulation against the outside heat. And then there is the behavioral side of survival. The concept of the siesta is not just a lazy cultural trope. It is a biological necessity in high-heat environments. In the Mediterranean and Latin American cultures, activity patterns were strictly dictated by the sun. Between the hours of 1 p.m. and 4 p.m., the world stopped. People retreated to the coolest, darkest rooms of their homes. This minimized metabolic heat production. When you exert yourself, your internal core temperature rises. By resting during peak heat, our ancestors prevented their bodies from reaching critical failure points. Diet also played a part. In high-heat climates, the traditional diet often centered around small, frequent meals. High-protein, heavy meals increase your internal body heat during digestion, a process known as thermogenesis. Instead, they relied on hydrating foods like melons, cucumbers, and fermented dairy products. These foods provided necessary electrolytes and fluids to keep the sweat glands functioning. But let's talk about the psychological aspect. Survival isn't just about not dying, it's about maintaining the ability to make decisions. When your core temperature spikes, your brain function declines. You become irritable, lethargic, and prone to poor judgment. Ancient cultures ritualized their survival to keep the mind sharp. They used textiles to create shade in marketplaces. They organized communal tasks for the early morning, and they established strict routines for water management. By turning survival into a set of daily habits, they removed the need to think about heat stress constantly. It became second nature. Consider the Khoisan people of the Kalahari. They possess an almost supernatural ability to track game in temperatures that would cause heat stroke in most modern humans. They move with an economy of motion. They don't sprint, they shuffle. They cover their skin in a paste made from herbs and earth, which acts as both a sunscreen and a way to hold moisture against the skin. They don't fight the heat, they mirror it. They move in sync with the environment. We have spent the last 100 years trying to conquer the heat. We build glass skyscrapers that act like greenhouses, and we rely on mechanical systems that fail the second the power goes out. We have become fragile. If the grid fails in a 120-degree heat wave today, the results would be catastrophic. Our ancestors, however, lived in the same conditions for millennia without a single circuit breaker. They understood something we have largely forgotten: the difference between comfort and survival. They designed their lives to accommodate the climate rather than trying to force the climate to accommodate them. They understood that you don't fight a 120-degree day, you hide from it, you shade it, and you wait for it to pass. We often view history through a lens of technological superiority. We look at a mud brick house and think, primitive. But that house is a masterclass in fluid dynamics and thermal regulation. It is a house that breathes. We have the technology to create hyper-efficient homes, yet we continue to build structures that are fundamentally at war with their own environments. Maybe the solution to our current climate crisis isn't just bigger batteries or more efficient solar panels. Maybe the solution is looking back at the logic of the past. If we took the architectural efficiency of a Persian wind catcher and combined it with our modern material science, we could cool our cities with a fraction of the energy we currently use. The heat is not an enemy to be defeated. It is a constant variable in the human story. We survived the ice ages with fire and clothing, and we survived the desert with shade and flow. We are a species defined by our adaptability. The question is, have we become too comfortable to adapt again? When we look at the ruins of ancient civilizations, we see a history of resilience. We see humans who looked at a burning sun and found a way to turn it into a manageable part of their day. They didn't rely on global supply chains for coolant gases or electricity. They relied on physics, architecture, and a deep understanding of their own biology. We are currently living in a period of unprecedented heat, and our reliance on mechanical systems is starting to show its cracks. The energy demand for cooling is skyrocketing, putting even more pressure on the very climate we are trying to survive. We are essentially cooling our interiors by heating up the planet. It is a loop that cannot continue forever. Perhaps the most important thing we can learn from our ancestors is that survival is a design problem, not just a technical one. We need to start building cities that work with the sun, not against it. We need to start designing our days around the natural rhythms of our biology. We need to rediscover the cooling power of shadow, airflow, and high-mass materials. The desert hasn't changed. The sun is just as hot today as it was 5,000 years ago. We are the ones who have changed. We traded our environmental intelligence for the convenience of a wall unit. But as the world continues to warm, that convenience is becoming a liability. History shows us that we are capable of surviving the most extreme environments on this planet. We have done it before. We have navigated the droughts, the heat waves, and the harsh, unforgiving landscapes of the ancient world. We didn't do it because we had machines. We did it because we were smart enough to align our lives with the physics of the world around us. The ancient humans who walked across the salt flats of the desert didn't have thermometers. They didn't need them. They felt the air, they read the shadows, and they lived in balance with the heat. As we move into an uncertain future, Maybe it is time to stop trying to overpower the climate and start learning how to live within it once again. After all, the environment will always be the final authority. We can either work with the heat or we can be broken by it. The choice, as it has been for thousands of years, remains entirely up to us.